Hi everyone, I'm here today to present you about the topic of laser. So throughout this presentation, we delivery into the key point of what is laser, importance of laser, how this laser works, properties of laser, type of laser that we have, advantages and disadvantages of laser with each used in industry manufacturing sectors and so on. So I hope that by the end of our time together, all of you have a better understanding of the topic that we have discussed today and how it will impact our lives. Before beginning on the topic, so I would like to introduce our group members. First of all, Nur Ifah Usna, then Nadira Aziz, Nur Aldira, last but not least, Irene Sophia, and lastly, Sri Shaviden, which is me.
Okay, first of all, what is laser? Laser is a device that. Next, these are the importance of laser in fiber optic. The first one is.
So next, how does a laser work? So a laser works by simulating the emission of photons in a process called stimulated emissions. So it consists of a gain medium such as crystal, gas or semiconductor placed between two mirrors. So when the gain medium is excited by an external source, it emits photons. So these photons travel back and forth between the mirrors, stimulating the emission of photons. This process created a cascade of photons, resulting in a coherent and collimated beam of light emitted through one of the mirrors. Next is properties of laser. So laser light possesses several unique properties that make it incredibly useful in various applications. So we have five of properties. So first, coherence. So laser light is coherent, which means that all the photons emitted by a laser have the same frequency and phase. So this coherence allows laser light to maintain its focus over long distances and produce interference pattern. Next is directionality. So laser light is highly directional and can be focused to a small spot even over long distances. So this make it ideal for applications such as laser cutting, welding and long range communication. Third, monochromaticity. So laser light is nearly monochromatic, consisting of a narrow range of wavelengths. This makes laser light ideal for application requiring a specific wavelength, such as spectroscopy and medical treatment. Next is brightness. So laser light is highly intense with a high power density. This high brightness make laser useful for application requiring high energy density, such as laser machining and material processing. Last, polarization. So laser light can be easily polarized, meaning the electric field oscillates in a specific direction. This property of laser light make it useful in applications such as optical communication and scientific research. So in summary, the unique properties of laser light, including coherence, directionality, monochromaticity, brightness, and polarization, make laser light invaluable tools in a wide range of fields and applications.
There is four types of laser. For the first one is the gas laser. For the second one is the solid state laser. And for the third one, liquid or fluid laser. And for the last one is the semiconductor laser. Role of laser in fiber optic. Laser plays several key roles in fiber optic communication. For the first role is the light source. Lasers are used as a high-intensity light source in fiber optic communication system. The coherent and monochromatic nature of laser light allows the efficient transmission of optical signals through fiber optic cables over long distance with minimal loss and dispersion. For the second role, signal transmission. Lasers generate the optical signals that carry data in fiber optic communication. The light produced by lasers is guided to the core of the optical fibers, where it travels by total internal reflection, ensuring minimal signal loss and high-speed data transmission. For the last role is data encoding. Lasers are often modulated to encode data onto optical signal. Modulation techniques use such as amplitude modulation (AM), frequency modulation (FM), and phase modulation (PM) are applied to laser light to transmit digital information effectively through fiber optic cables.
Next, we will discuss about the advantages and disadvantages of the laser. First of all, we take into look into the advantages, and firstly, laser beams can be focused to a very small point, allowing for highly precise cutting, engraving, and surgery with minimal damage to surrounding areas. Taking an example, in manufacturing of microelectronics, lasers are used to precisely cut and drill tiny holes in circuit boards with accuracy down to micrometer scales. And second advantages is laser system can achieve high level of accuracy and repeatability crucial in fields like manufacturing and surgery. So for example, in aerospace engineering, lasers are used to align components during assembly to ensure precise fit and alignment of parts. And last but not least, laser processes are typically faster than traditional method, making them efficient for manufacturing and medical procedure. So an example, laser cutting machine are employed in automatic manufacturing to rapidly cut sheet metal for body panels, offering quicker production cycles comparatively to traditional method like stamping. Next, we look into the disadvantages of the laser. So laser system can be expensive to purchase, operate and maintain, especially high power industry lasers. Next, laser system require regular maintenance and upkeep to ensure optimal performance, which can add to operating costs. Taking an example like a laser hair removal, regular maintenance of laser system in medical facilities is a crucial to ensure consistent performance and patient safety during procedures. And last but not least, it's about reflective surfaces. So certain material with highly reflective surfaces can reflect the laser beam, making them challenging to work with the potential hazardous. For example, laser welding of highly reflective material like copper can be challenging due to the beam deflection.
Application of laser. The first one is medical application. In medical application, laser used for laser surgery for precision cutting and tissue cauterization, and then it's used in therapy for dermatology and ophthalmology, and also used in eye surgery for vision correction. And then the next one is industrial application. In industrial application, laser used for cutting and welding in manufacturing process. Also used in laser marking and engraving for product labeling and identification. And also used as drilling for precise hole making in material. Okay, for the next one is communication application uses. And then in communication application uses, uh, fi- laser used for in fiber optic communication using laser light for high speed data transmission, and also in laser printing for high quality printing in office and commercial setting. Okay, the next is scientific application. In scientific application as spectroscopy using lasers for chemical analysis and material characterization. Characterization, sorry. Okay, it also used for cooling and trapping of atoms for fundamental physics research, and also used for interferometry for precise measurement in metrology. Next is defense and security application. Defense and security application use in use as laser targeting and range finding in military and defense system. It also used for laser weapon for defense and deterrence. Okay, the next application is entertainment application. Laser used for laser light shows for concert, event and entertainment venues, and also used for laser display in theater, theme parks or exhibition. Okay, the last one is environmental and remote sensing application. Uh, for example, is LiDAR, light detection and ranging, for remote sensing and environmental monitoring. In environmental and remote sensing, it used as laser-based sensor for pollution detection and atmospheric study. In conclusion, population inversion is a critical aspect of laser operation, achieved by pumping atoms to higher energy levels to create an imbalance favoring higher energy states. This sets for the stage for stimulated emission, where a photon triggers the emission of coherent photons, leading to the coherent light generation essential for laser functionality. The lasing action in laser hinges on stimulated emission and presence of a gain medium for light amplification. This principle find application in optoelectronics, such as in SQW laser, where even a small current can induce population inversion and stimulate emission.